So with this worksheet, we're going to go through some word problems and I'll give you some tips and tricks for what to look for and really interpreting what are they asking you to do, because that can be a difficult part of a word problem as you get into the math of it, and then you might end up with an answer that doesn't even answer the question. So we always want to double check that when we make our sentence answer. Now, with the problems on this worksheet, they all use, or at least most of them use tools that we've already talked about in the previous videos and even the previous weeks. So this could be a great worksheet to try before you actually watch the video. And with that, see if you can get to the same solutions. Even if it isn't the same route to the solution, that's totally fine. But it's a good way to kind of get that practice to see how you're doing. So these are just some helpful steps. You don't necessarily need to follow these steps for every single problem, but especially step 1 and 2, to read a problem and then read it again is very good to do. Just to make sure that when you're you don't want to skim read word problems, you want to really pay attention to the information they're giving you, even though maybe sometimes they give you too much information, but paying attention to what will you need to solve the problem and then what are you looking to find. With the problems, I like to go through and underline key information and even rewrite some pieces outside of the problem just to kind of organize it before you get into solving. If you're going to be using any variables, and typically it's for the value that's unknown that you're going to look for, you can define that variable. With defining variables, you can choose basically any letter to represent your variable, but definitely avoid certain letters. Avoid using the letters I, E, and O. I and E are actually numbers in mathematics. In fact, in our class, we'll talk about what E represents eventually when we get to financial mathematics. So we want to avoid I and E because they have mathematical properties. O we just avoid because it can turn into a 0 by accident. So you just want to be careful of that. All right, and then once we get our variables all set up and writing down any formulas that we might use, then we could go ahead and start plugging in and solving. And that's where word problems can be difficult too, because where I can give you examples, there's so many different forms, and it's more this problem solving nature that we want to work on of you have this puzzle and they give you some pieces. How can you put those puzzle pieces together based on all of your mathematical knowledge? So it draws from a lot of different areas that you've already learned about. And then once we get to an answer, we're going to write a sentence. And then a great last step to do is just take a moment to make sure it makes sense. So go back and even maybe read the problem one more time and see if your solution fits with what they're asking. All right, so this first one, we have a crepe recipe and it has 2 eggs, 1 cup of flour, and 1 cup of milk. So we have this recipe here. And what we want to do is see how much flour. So this is going to be our unknown that we want to solve for. We want to end up describing how much flour we want. And something I might do here too is if that's my unknown, I might put the units next to it. So when we get flour out, it should be in cups. And so how much flour would you need if you use 5 eggs? So we have these kind of 2 scenarios here. I'm just going to write it off to the side. So reading through again, we have the crepe recipe with 2 eggs, 1 cup of flour, and 1 cup of milk. And then we want to do is fit this next scenario where we don't know how much flour we have, but we know we have 5 eggs. So we have 5 eggs. They're not mentioning anything about milk, so that's just kind of extra information. In fact, probably is not going to come up at all, so I'm just going to scratch that out. And then we'll have X amount of flour. Now this scenario here that we've seen before in terms of describing one case, and we want to compare it to another case to solve for the unknown, this is a proportion problem. So we could do is set up proportions where we know that it would be 2 eggs to 1 cup of flour. And what we can do is set that equivalent to if we had 5 eggs to our unknown. And then we'll cross multiply. So x times 2 eggs equals 1 cup times 5 eggs. Divide by 2 eggs. And with that, the units of eggs will cancel out, so we'll have something in cups. And then for the number part of it, it'll be 1 times 5 divided by 2, so you'll get 2.5 cups out. And then what we want to do is make a sentence at the end, and we could go back and read and make sure this is fitting. So we had the crepe recipe, and we want to answer the question, how much flour would you need if you use 5 eggs? We would need 2.5 cups of flour if we use 5 eggs. And that would be our final answer. Everything would fit together. All right, this next one's going to deal with a little bit of geometry. What we could do is, there's not much in terms of reading the question, so we want to find the area of the shaded region. So just to be sure we recognize that's what's happening on the outside here. And I have 2 shapes occurring here. I have a square, that 4" by 4" square, and we have a circle. So what I could do is kind of map out, if I want this area of the shaded region, something I'm going to need to do is take the area of the circle. I need the area of the larger piece. And I'm going to go ahead and write in my formula. So area of a circle is pi r squared. And once we have that larger area, what I want to take out of that area, because if I did that formula, I'd have area for this whole thing, but I want to take out the area of that square. So what I'm going to do is subtract area of the square, which our formula for that was just taking the side length squared, which we could actually already fit in there. This number 4 is representing the side length of that square. So eventually, when we get to our calculation, we'll have 4 squared right there. Where we run into an issue is getting radius for the circle. Now the 4 does not represent radius or diameter here. Again, we need a value that's going through the center of the circle. So in terms of radius, that would be our radius, kind of going from the center of even the square out to the corner. But what we can use is, what if we extended this to represent the diameter going across the whole square there? Then what we end up with is a right triangle. In fact, I'll even draw the right triangle off to the side, where this hypotenuse is representing the diameter of the circle. We have a 90-degree angle, that's 4 inches, 4 inches. So using our Pythagorean theorem, what we can do is solve for the diameter. So we take the hypotenuse squared is equal to leg squared plus leg squared. And then we'll go ahead and start simplifying down. So we should end up with, if we take the square root of this, a diameter of about, and we'll go to 4 decimal places for accuracy here, 5.6569. So with that, then I could get the radius out, and the radius should be taking that 5.6569 and dividing it in half, which will be a 2.8285. So now we can plug into the area of the circle. So let's go ahead and go back to our formula to get this area of the shaded region. And what we'll take is area of the circle, so pi times r squared, which r is the 2.8285. Square this minus the area of the square, which will be 4 squared. And then you could just plug all of that into the calculator at once, and what we should get is 9.134. So to answer our question, what we could do is say the area of the shaded region is 9.134, and then for our units, we're working in inches, and it's an area, so it should be inches squared. That would be our final answer. All right, we have a ream of paper, 25 inches by 38 inches, weighs 80 pounds. And then we're going to look at this other ream of paper, 35 by 45 inches of the same grade, but we don't know the weight. And what we're going to throw in here is that a ream of paper includes 500 sheets of paper. All right, so we have one scenario here where we get kind of the size of the paper and the weight that goes with it. And then we get this other scenario where they give us the size of the paper, but we don't know what it weighs. That's going to be our unknown. And then this final wording here of telling you about 500 sheets of paper is just to give you an idea that the number of paper included in the two are the same. So that's not going to affect weight. What will affect weight is the size of the paper. It's kind of like if you stack 500 sheets of paper that are this size versus this size, it's like in terms of height, it should be pretty much the same, but when you make it larger, that's going to be what adds weight. So something we're going to think about here is area. How much area does the small amount of paper cover versus the large amount of paper? Because then we're getting an idea of volume, where it'd be the area of the paper times the width of the stack. But we can kind of ignore the width of the stack because it's the same. It's 500 sheets of paper for both groups. So let's talk about this first ream. So let's call this ream A. So that's 25 inches by 38 inches. So what I'm going to do is go ahead and calculate area that paper covers. So 25 times 38, which is 950 square inches. And then that's going to be matched up with a weight of 80 pounds. Then ream B, for area, we'll have 35 by 45, which is 1,575 square inches. And then for weight, that's our unknown that we need to solve for. So this is that case like we saw in number 1, where we have these two scenarios, and we have information in terms of area and weight for one, and we have area for the other, but we don't have weight. So this will be a proportion problem, and we need to use the area when we set up the proportion. So 950 square inches to a weight of 80 pounds equals, and then 1,575 square inches to, and then our unknown. So we're going to cross multiply. So we'll have x times that 950 and 80 times the 1,575, and then we're going to divide by 950. So when we solve numerically, plugging those into the calculator, we should get 132.6316. And then for units, those square inches will cancel out, so we're left with weight, which is exactly what we want. So to make sure we answer the question, they want to know, what will this ream of the same grade weigh? This ream of 35-inch by 45-inch paper will weigh 133 pounds. Again, when you make your sentence, round to what feels comfortable. If you wrote the whole long number with the decimals in there, absolutely correct. It's just we can round there how we need to. All right. Number 4 here, in a class action suit against a large corporation, a group of 5,675 plaintiffs won $4.9 billion. If the attorney fees were 40% of the settlement, how much did each plaintiff receive? So, our important information, we know how many plaintiffs there are. So when we figure out this amount of money that they won, we're going to want to divide it up by that amount. This is their initial winnings that they got, the $4.9 billion. And then what we have are attorney fees. So that's something we're going to have to pay out from the winnings. So this is going to decrease the winnings amount by 40%. So when they give you units like this, $4.9 billion, we're going to want to change that to a big long number because this number is going to decrease down and can be hard to work with as those units change. So it can just be better to take that 4.9 billion and switch it over to the long form, which, let's see, we'll have 4 and then 900 million, thousands, hundreds. So that would be the equivalent of 4.9 billion. Then what we want to do is take 40% out. So what we're going to do is subtract out 0.4 times that 4 billion. And that difference will give us their actual winnings. So that'll be 2,940,000,000, and then a lot of zeros. So with that, we took out the attorney fees. Now what we need to do is divide this up amongst the plaintiffs. So I have this number, and this math isn't the most organized, but just so I don't have to keep writing down that large number, we want to take those winnings and divide it up by the 5,675 people. So with that, we're dividing it among the plaintiffs. So if we put that in the calculator, we should end up with $518,000.61 and then 67 cents. So how much did each plaintiff receive? Each plaintiff received $518,061.67. All right. Excuse me. A car is driving at 100 kilometers per hour. And what is the car's speed in miles per hour? So we're going to have is this rate, and we want to change it to a new rate. So this is going to be a rate conversion problem. So 100 kilometers per hour, and we want to change it to something in miles per hour. So what's actually going to happen here is in the numerator, we're going to go kilometers to miles. In the denominator, when we looked at rate conversions, we also converted the denominator. However, it's staying put at hours, so we're actually not going to need to convert it. So all we need to do is find that conversion rate between kilometers and kilometers to miles. So we want to get rid of kilometers, so put in the denominator, and we want units of miles. And the conversion goes for 1 mile, there's 1.609 kilometers. So when we do that, kilometers will cancel out, and then we'll have miles in the numerator, hours in the denominator, just as we like. So if we take 100 divided by the 1.609, this should be 62.15 miles per hour. So what is the car's speed in miles per hour? The car's speed is 62.15 miles per hour. All right, so we have these last three questions tied together with this information up here. So we have two rental companies. Rental company A, they're charging $59.95 a day with no mileage limitations for a compact car. Rental company B, they're going to be charging $39.99 a day plus 10 cents per mile. So what we want to do is compare these two rental companies. So what we want to do is compare, what if we were driving to Seattle? We want to find which would be cheaper. So that's what we're looking for here. So we want to do a cost comparison. If we drive to Seattle, which they're giving us the number of miles of 120. So let's compare rental company A with rental company B with how they would calculate those charges. So with rental company A, and I just realized I switched my colors around for consistency. Let's just get that right. So company A is just $59.95 a day. So if we're driving to Seattle, it doesn't even matter how far we're going with company A. If I'm taking that car out for just one day, I'm going to be paying $59.95. So nothing to really calculate there. It's just that daily charge. If we were renting it for more days, then we'd have to start multiplying. But with this, for a single day, just $59.95. For rental company B, we're going to have the $39.99 charge plus 10 cents for each mile. Now this calculation of this is 10 cents per mile. So what I want to do is add on 10 cents for each mile that we travel, which will be the 120 times. So since we have the 120 miles, and the calculation that comes through with that is multiplication. So we take the 10 cents times 120 to figure out how much are we adding on for mileage. If we put that in a calculator, it'll be 51.99. So in terms of a comparison of which is cheaper, it would be rental company B. So rental company B is cheaper if you drive to Seattle and back in one day. All right, with this next one, similar idea, we're just changing the distance. So now we're going to go to Portland, just 230 miles away. So rental company A, if this is a one-day trip, then it's just $59.95. For rental company B, we'll have the $39.99 charge plus 10 cents per mile. So I'll have the 10 cents times 230, and that'll bring us to $62.99. So for this scenario, rental company A is cheaper. So that'll be cheaper if you drive to Portland and back in one day. All right, and then this last question is going to ask, how many miles would we travel for it to be the same? So we want to see the same cost come through for just a one-day rental. So what we could do is kind of see a theme that was happening with our calculations here. Rental company A for one day is just always $59.95. So that was always true. Then we want to see, where is that going to be the same as? So same as would bring through equality. So where does that equal what we're doing for company B? And the theme with company B is we're taking that $39.99 plus 10 cents per mile. And what we want to do is actually find how many miles. That's our unknown here. So what we're going to do is we'll have that 0.1 times the number of miles, which in this case is x. And that becomes an algebra problem of solving for x. So what we'll do is subtract 39.99 from both sides first. So that'll be in 1996 equals 0.1 times x. Divide by 0.1, divide by 0.1, and we'll get x equals 199.6. So what we would do is we would have to drive 199.6 miles for the costs to be the same. All right, so those are some examples of word problems. Again, there are so many more out there. It's just you can't go through every single example, but it's this idea of looking through the wording, kind of collecting what you have, and then from there drawing from tools that we've already learned about.